Good day everyone. So our content for this video is center and moment of mass. Mass is concentrated about one point, which creates equilibrium or simple word balance. This point is called the center of mass or the center of gravity or the centroid. And when we multiply the mass of a particle by its directed distance from this point is called the moment of the particle, and it measures the tendency of the path to produce a rotation about that point. So before we start for our example, literally moment is equals to mass times distance. So this, I will give you an example for a one-dimensional. This is our sisu, our fulcrum or the center. First object which has 12 kilogram mass and 5 meters away to our fulcrum. This became negative because it is located in the left side, or we compare it in when we graph, this side is negative. Our second object, which has 10 kilogram mass and 10 meters away to our fulcrum. The moment of our second object has 10 times 10 is 100 kilogram times meter, and our first object, which has a moment of 12 times negative 5 is negative 60 kilogram times meter. So as we observe, our second object has the most mass. So our seesaw will rotate in clockwise direction. So our problem is to we need to find the center of the mass to make this two object uh, to balance the seesaw. To find the center of the object, we need to consider our x to the origin or 0. This is the equation to find the center of the seesaw, the center of the mass, if it is located in the x-axis. So x bar is equals to moment of the origin over 2 the mass is equals to m1 or the mass 1 times x1 or distance 1 plus m2 or mass 2 times distance 2 or x2 over the total mass of the object m1 plus m2. So x bar is equals to m1 plus x1 plus m1 times x1 plus m2 times x2 plus so on over m1 plus m2. So our m1 has the mass of 12 times distance negative 5 plus m2, which is 10 times distance 2 is equals to 10 over 12 plus 10. So 12 times negative 5 is negative 60 plus 10 times 10 is 100 over 22 is equals to negative 60 plus 100 is 40 over 22. So our centroid or the fulcrum of the mass is located in 1.82. So redraw. This is the so the this is the illustration of the sisu in balance. So finding in y-axis in two-dimensional system, this is the formula m1 y1 times y1 plus m2 y2 over m1 plus m2. Next, we're already done about for the example in one dimension.